Welcome. You've arrived at the edge of night, where thought slows and time stretches gently. Perhaps you are lying in bed, or maybe listening from a dimly lit room. Outside your window, the sky presses quietly against the dark. The stars may be hidden behind clouds or city lights, but they are there, still watching, still shining. In this long and gentle journey, we will drift across time, across continents, across ways of seeing. Together, we will explore the history of how human beings have looked up into the sky and asked the oldest questions. Not with urgency, but with patience. Not with noise, but with silence. We will meet stargazers from forgotten cultures, scientists with ink-stained fingers, monks who copied the heavens by candlelight, sailors who trusted the sky, and modern astronomers listening for whispers between stars. This is not a story of explosions and rocket ships, though we will touch space eventually. This is the story of Skywatchers, of those who listened to the sky before we could hear it, who read it before we could measure it. Let your breath slow. Let your muscles soften. Let your thoughts become as quiet as the turning of the earth. Now imagine yourself standing beneath an ancient sky. No satellites, no airplanes, just the wind, and the stars, as steady as always. Let us begin. Long before the names of Copernicus, Galileo, or Newton, the sky was already being studied by countless unknown souls. They lived in caves, in temples, in forests, in silent cloisters. Most of them left no books, no star charts, only traditions. Only quiet impressions pressed into stone or passed through spoken word. Some were women, some were monks, many were forgotten. Yet their eyes, just like yours, turned upward. Let us walk among them now. First eyes. Before history, imagine yourself in a time with no writing, no cities, no metal. Only the sky and the ground beneath your feet. Each evening, the stars rise again. You cannot read them, not in the way we think of reading, but you feel their rhythm. In caves across Europe, Africa, and Asia, archaeologists have found markings that seem to track the phases of the moon. In Lascaux, France, 17,000 years ago, a series of dots near an image of a bull may have represented the Pleiades, a small cluster of stars that still guides our gaze today. These were the first calendars, not carved for beauty, but for survival. When to plant and to hunt, when to expect rain. And who marked these stones? No one knows. But scholars now suspect that the women of those communities may have been among the first Skywatchers. They kept time with the moon, tied to fertility and the rhythms of life. They noticed when the sky changed because their lives depended on it. The Sky in Song, Aboriginal and Indigenous Astronomy. Move forward now, gently, thousands of years, to Australia. To the First Nations people whose stories reach back over 60,000 years, to them, the sky was not a place of silence. It was filled with voices, songs, memory, the emu in the sky, not made from stars, but from the dark patches of the Milky Way, told them when to harvest eggs. Stories in the stars taught children how to live, how to move, how to remember. These were not myths in the way we use the word. They were practical, generational knowledge encoded in poetic form, passed from elder to child, not on paper, but through voice and ritual. And still, the songs remain. Still, the stars remember. Monks and shadows. In the quiet rooms of medieval monasteries, thousands of miles from Australia, another form of watching took place. Monks, tucked away in stone chambers, copied manuscripts by flickering candlelight. Among the texts were lists of eclipses, diagrams of planetary motion, calendars that tied celestial cycles to Christian rituals. Some built simple observatories using only a hole in the wall and a shaft of sunlight, a stick in the ground, a shadow moving slowly across the floor. From this, they mapped the heavens. We think of science as modern, but the roots are ancient and devotional. To study the sky was to move closer to the divine. The act of watching, of recording, of repeating, it was not for fame or profit. It was an act of quiet service. And so, the stars were recorded by hands now long gone. Women in the shadows. It was in the 19th century, long after telescopes had transformed astronomy. Women entered the field in numbers, but rarely in recognition. At the Harvard College Observatory, a group of women known as the Harvard Computers were hired to catalog the positions and brightness of stars. Among them was Henrietta Swan Leavitt, who discovered a pattern in the pulsing of variable stars. Her insight became the key to measuring the size of the universe. She worked in silence. She did not receive awards. But her light, like the stars she measured, traveled far beyond her time. And even further back, in ancient Mesopotamia, in India, in China, records mention women who watched the skies, calculated calendars, wrote treatises, only to have their names fade beneath the weight of centuries. Still, the heavens held their work. Still, the earth turned beneath their feet. The invisible thread, from Neolithic cave markings to medieval monastic calendars, from indigenous sky songs to the meticulous tables of forgotten women, there is a thread that weaves through it all. A thread of observation, of patience, of reverence. They may not be in textbooks. Their instruments may have been crude or lost. Their methods may seem strange. The sky does not change its language. It's only the ears that listen. And so we begin, not with great discoveries, but with forgotten eyes. Eyes that looked up, night after night, and saw something worthy of remembering. Something sacred, something orderly, something vast. Now, let us gently follow that thread to one of the oldest forms of skywriting. Not words, but maps made of stars. In the next segment, we will explore how ancient people mapped the sky, sometimes in stone, sometimes in stories, and how those maps guided them through darkness. Let us turn the page. Now imagine yourself walking beneath a clear night sky. It's in a time before paper, before compasses, before even numbers as we know them. Above you, the stars shimmer, not in silence, but in meaning. In every corner of the ancient world, people charted the sky. It's not always with ink or symbols, but with memory, with monuments, with stones aligned carefully over time. Long before telescopes, they mapped the heavens. Not just for wonder, but for survival. Let us walk into that ancient darkness and look at how early humans made maps of the stars, not with ink, but with time. Nabta and the stones of the sky, we begin in the Nubian desert of southern Egypt. Here, near what is now known as Nabta, a circle of stone still stands. At first glance, it resembles other megalithic structures, but when examined closely, the alignments speak of astronomical intention. Some of the stones are thought to mark the summer solstice, as the sun rises and sets along lines formed by their arrangement. Dating to nearly 7,000 years ago, this circle may be among the earliest known astronomical observatories. It was not built quickly. Each stone had to be transported, positioned, observed over seasons, over generations, and yet no one wrote instructions. The knowledge was passed by demonstration, by repetition, by patient watching. Imagine a quiet gathering of figures at dawn, watching the light stretch across the desert, waiting for it to touch a particular stone. This was their map, the earth and sky joined by intention. The celestial blueprint of the pyramids. Farther north, the great pyramids of Giza rise above the sands. Much has been speculated about their purpose and construction, but among the more subtle details is their alignment. The sides of the pyramids are nearly perfectly oriented to the cardinal directions: north, south, east, and west. Some researchers believe the builders used stars to align them, particularly a pair of stars in the constellation Ursa Major. Imagine standing where the builders once stood, using simple tools: a plumb line, a shadow, a pole to align massive structures with the distant stars. In doing so, they fixed their legacy not only in stone, but in the sky. The Nebra sky disk. Now we cross time and geography again, arriving in what is now Germany. Buried for thousands of years and unearthed only recently, the Nebra sky disk is one of the oldest known attempts to depict the heavens on a physical object. Made of bronze and inlaid with gold, it shows a crescent moon, a full moon, and a cluster of stars believed to represent the Pleiades. The disk is small enough to be held in your hands, yet it contains the cosmos. Its purpose is still debated. Is it a ritual object, a teaching tool, a sacred calendar? Whatever its role, the person who made it had watched the sky, had measured, had imagined, and then had tried to capture the order of the heavens in something as ordinary as metal. Imagine holding it now, cool in your palm, heavy with mystery. Stonehenge and the machinery of the heavens. Step next to the green fields of southern England, where Stonehenge rises from the earth like the bones of time itself. The outer ring and inner horseshoe of stones align with the sunrise on the summer solstice. Each year, as the sun climbs above the horizon, it shines directly through the center, lighting the heart of the monument. But Stonehenge is more than just one alignment. Its structure suggests ongoing observations, possibly tracking lunar cycles and eclipses. There were no telescopes here, no written records that survive. And yet, the entire monument functions as a celestial calendar. Imagine the patience. The stones were dragged for miles, arranged over centuries, by hands that knew the rhythms of the sky. They built not just for themselves, but for the future. For you, perhaps. To stand among them and feel the weight of the heavens pressed gently into the land. Oral maps of the sky. Not all maps were made of stone or metal. Many were sung. In Polynesia, wayfinders memorized vast stretches of ocean by learning the positions of stars. These star paths guided them across thousands of miles, long before compasses or sextants. In the Arctic, Inuit hunters mapped the stars with story. In the Americas, the Maya recorded planetary movements with astonishing precision, carving them into codices and temples. And among many indigenous groups, the sky was not above, but around, a dome enclosing a world of meaning. These maps lived in the mind, passed through breath and memory. They were never drawn, but they were never forgotten. Why map the sky? Why did ancient people mark the solstices? Why did they track the planets, chart the moon, tell stories about stars? Partly for survival. To plant, to harvest, to navigate. Partly for devotion. To honor the gods, to predict sacred days, to perform rituals at the right time, and partly for wonder. To see a pattern in the darkness is a kind of peace. To find meaning in the stars is a way of making the world feel less random, less cold. Even now, with all our satellites and sensors, people still look up and trace imaginary lines between stars. We still name constellations. We still seek comfort in patterns written across the void. In our next segment, we will explore the tools that brought the sky even closer. The instruments of wonder, the astrolabe, the armillary sphere, the quadrant, and beyond. Not digital machines, but elegant devices powered by sunlight, shadow, and time. Let us walk into the workshop of the early astronomer. Let your breath fall into rhythm, like the turning of a gear, or the quiet swing of a pendulum. In this next phase of our journey, we'll enter the workshops, observatories, and quiet towers where Skywatchers built instruments. Not machines of power, but tools of understanding. These were not only objects of precision, they were objects of beauty. Brass and bronze, polished and engraved, circles within circles, mechanisms with no engines, only patience. Let us begin with a shape that changed everything, the circle. The astrolabe. A map of the heavens in the palm of the hand. Imagine holding a flat disc of metal, cool and weighty in your hand. Etched onto its face are lines, curves, symbols, a language of light and motion. This is an astrolabe, one of the most remarkable scientific instruments of the pre-modern world. First developed by the ancient Greeks and later perfected by Islamic astronomers. The astrolabe could calculate time, measure the height of stars above the horizon, and determine direction. It was a Skywatcher's compass, calendar, and calculator all in one. Picture a scholar standing on a rooftop in 10th century Baghdad. The call to prayer echoes softly across the city. She raises the astrolabe to the stars, aligns it carefully, notes the angle, and marks the moment. The heavens are no longer distant. They are drawn near, framed in brass and thought. The armillary sphere. A celestial skeleton. Now imagine a delicate construction of rings, each one representing a celestial circle, the equator, the ecliptic, the meridians of the sky. This is the armillary sphere, used to model the heavens and teach the motion of the stars and planets. One can spin it gently, watching how the heavens rotate around the earth, as once believed. In ancient China, similar instruments were developed and refined with astonishing complexity. Bronze circles, intricate gears, even water clocks were used to model the skies with incredible accuracy. The emperor's astronomers kept careful records of eclipses, comets, and planetary alignments. To predict the heavens was not only a scientific act, but a political and spiritual one. Imagine them watching the stars not only for knowledge, but for omens, signs of favor or change, of blessing or warning. The quadrant and sextant, measuring with shadows, move now into the world of sailors and surveyors. They too needed to know where they were, especially when no land was in sight. The quadrant and later the sextant allowed navigators to measure the angle between the horizon and a star, most often the sun or Polaris, the North Star. From that angle, they could estimate their latitude, their position on the globe. Imagine a sailor on a creaking wooden ship in the middle of a great sea. The wind is quiet, the night is dark. She holds a brass instrument steady, lines up the star, and makes a mark. From this mark, she finds her place in the world. No GPS, no maps, only stars and shadows. The Antikythera mechanism. A machine lost in time, and then, from the depths of the sea, came something almost mythical. Discovered in a shipwreck off the coast of Greece, the Antikythera mechanism is a complex device of gears and dials, dated to the 2nd century BCE. For decades, its purpose was a mystery. But slowly, with X-rays and reconstruction, its secrets began to unfold. It was a computer of sorts. A mechanical device capable of predicting eclipses, tracking the moon and planets, and marking significant festivals. Imagine winding a small handle, turning time itself forward, watching the heavens advance on a series of bronze dials. It is both strange and familiar, ancient and modern, a relic of genius lost to time and then recovered. Why instruments? Why build these devices? Why spend years engraving, calibrating, adjusting, improving? Because the sky is vast. Because the human hand longs to make what it sees into something it can hold. These instruments are not just tools, they are bridges. Between eye and understanding, between mystery and explanation. Do not reduce the sky, they reveal it. And even now, In museums and quiet collections, these devices still wait. Their brass still gleams, their circles still align. They still speak, softly, to those who know how to listen. Now, let us move forward again to the skies of conflict. In the next segment, we will explore how skywatching and space science were shaped by war, empire, and power. From the Cold War to colonial astronomy, the heavens have never been neutral. The sky belongs to no one, and yet, throughout history, powerful nations have tried to claim it, to map it, measure it, name it, and sometimes to use it for control. In this segment, we move into a more modern landscape. A world of telescopes built by empire observatories planted like flags, and equations written in the language of conquest as much as curiosity. Yet even here, the story of the sky remains deeply human, shaped by dreams, rivalry, and resistance. Observatories of empire in the 18th and 19th centuries, as European empires expanded across the globe, they brought with them not only armies and commerce, but also science. Astronomy was a key part of this endeavor. Observatories were established in colonial territories, Cape Town, Madras, Hong Kong, and beyond. These were not simply centers of learning, they were tools of imperial administration. Mapping the stars allowed colonial governments to improve navigation, calculate longitudes and time events with greater precision. Accurate timekeeping meant better coordination of shipping and military movement. But the skies being studied were not empty. They hovered over living worlds. Local peoples with their own knowledge systems, sky traditions, and calendars. Some local scholars were invited to participate in the work of the observatories. Others were sidelined. A few preserved their own knowledge quietly, passing it on in stories and songs even as foreign instruments charted above. Picture a British officer peering through a telescope in Calcutta, aligning it to a star. In the same moment, just beyond the gates of the compound, a local elder points to that same star and recites a verse passed down from generations. 2 ways of seeing, 2 ways of knowing. The great equatorial telescopes. With industrialization came greater precision. Telescopes grew larger, heavier, and more complex. They required domes, gears, and tracks. Entire buildings built around the needs of a single lens. One such creation, the Leviathan of Parsonstown, stood in Ireland during the 1840s. At the time, it was the largest telescope in the world. It revealed previously unseen shapes in the night sky, spiral structures that would later be called galaxies. But these great machines were not easily accessible. They were expensive, often private, and isolated. Knowledge gathered in these domes did not always flow freely. They represented something more than just scientific progress. They embodied ambition, the belief that the universe could be known if we just looked hard enough. Imagine standing beneath one of these great domes, the massive tube turning slowly above you, whispering in gears. The air smells of oil and stone. The stars wait in silence. Cold War skies and the space race by the mid-20th century, the study of the heavens took a sharp turn. The sky became a battleground, not of bullets, but of prestige. The launch of Sputnik in 1957 startled the world. A tiny Soviet satellite had pierced the upper sky, and with it came a wave of urgency. The United States responded with NASA, and thus began the space race, a contest not just of rockets, but of minds. Astronomy and physics were now geopolitical tools. Telescopes became more powerful. Radio dishes scanned the heavens. Funding flowed into universities and laboratories. Behind the curtain of global rivalry, some of the greatest discoveries in cosmology were made. Quasars, pulsars, background radiation, black holes, and yet, as the rivalry intensified, so too did the secrecy. Some sky watching became military surveillance. Satellites with eyes. telescopes that could see not just stars but cities. The heavens, once sacred, now held missiles. Indigenous astronomies in a colonized world, but in the shadows of these empires and conflicts, other sky stories continued. Indigenous knowledge systems, though suppressed, survived. The Yolngu people of northern Australia mapped the Milky Way with stories. The Zuni and Navajo observed Venus with care. In the Andes, Quichua traditions held the Pleiades as a signal for planting. These traditions were not naive or romantic, but were based on careful observation refined over centuries. In recent decades, a new movement has emerged to listen again to these voices, to bring different ways of knowing into dialogue. Some modern observatories now collaborate with indigenous communities. They seek not only permission to build on sacred land, but wisdom about what the sky means beyond data. Imagine a gathering where physicists and elders sit together beneath the stars. One speaks of light years, another speaks of ancestors. Both look up. The sky as a shared history. The sky has been used for power. Yes, for control, prediction, and sometimes fear. But it also remains the most democratic of landscapes. You cannot fence a star. You cannot tax a sunrise. Every human who has ever lived has seen the moon. Every empire, no matter how vast, has faded beneath the same quiet constellations. Even now, in an age of satellites and artificial light, the stars still wait, unchanged, unclaimed. To the golden moments of Renaissance rediscovery, to the revival of ancient knowledge, and the thinkers who brought the stars back to the center of thought, imagine you are seated at a narrow wooden desk. Candlelight flickers on parchment. It's outside, a chill breeze stirs the trees, but inside, the air is filled with silence, thought, and ink. Here, across centuries and continents, scholars bent over equations, sketches, and celestial charts. Their names would one day be remembered, though many lived in obscurity, or worked under threat, or died forgotten. Yet through their eyes, the heavens opened again. This segment is a slow procession through lives that shaped the way we see the sky. Thinkers who carried light through dark times. Each one a quiet star in the history of knowledge. Aryabhata. Circles in the Indian sky in 5th century India. Aryabhata composed his great work. The Aryabhatiya, at just 23 years old, he described the Earth's rotation on its axis and proposed that the apparent movement of the stars was due to this rotation, not the stars themselves circling us. He estimated the length of the solar year with stunning precision centuries before the development of European calendars. His mathematics were complex and elegant, filled with signs and place value systems, all aiding the calculation of planetary positions. Aryabhata's world was filled with rhythm. The rhythm of orbits, shadows, eclipses. His work would ripple through generations, preserved in Sanskrit commentaries, and later translated into Arabic. Imagine him standing beneath a sky in Pataliputra, observing the moon's curve, wondering how far away it truly was. Al-Biruni, curiosity without borders. Now we journey to 11th century Khwarezm in present-day Uzbekistan. Here lived Abu Rayhan al-Biruni, a polymath of boundless curiosity. He wrote over 100 books, many on astronomy, geography, and mathematics. He calculated the radius of the Earth using shadows and angles, and came remarkably close to modern measurements. He also wrote about the phases of the moon, the cause of tides, and the movement of the planets. But what makes al-Biruni remarkable is not just his precision, it is his attitude, approached science as a dialogue. He traveled to India, studied Sanskrit, and wrote respectfully about Indian astronomy and philosophy. He compared systems without declaring one superior. always seeking understanding rather than conquest. Picture him seated, cross-legged, scrolls spread out before him, translating Sanskrit star charts by lamplight. His mind wandered across languages, cultures, and stars. Copernicus. The Quiet Revolution in a quiet tower in Poland. Sometime around 1510, Nicolaus Copernicus rearranged the universe. He proposed that the Earth moved around the sun, not the other way around. It was not the first time such an idea had been suggested, but Copernicus gave it form, argument, and quiet certainty. He delayed publishing his work until late in life, perhaps aware of the upheaval it would cause. His De Revolutionibus Orbium Coelestium laid the groundwork for a radical shift. Suddenly, Earth was no longer the center. The sky no longer revolved around us. And with this came humility, a new sense of scale, the beginnings of modern astronomy. Imagine the long winter nights, Copernicus sketching orbits with a steady hand, turning the heavens inside out on a sheet of paper. Galileo. The telescope and the trial Galileo Galilei took the next step and paid the price. In 1609, he turned a telescope to the sky and saw what no one else had seen. Mountains on the moon, moons around Jupiter, phases of Venus that confirmed the Copernican model. He published his findings. He wrote in Italian, not Latin, so more people could understand. He mocked old beliefs. He debated. And then came the trial. The church demanded silence. Galileo was forced to recant, to deny what his own eyes had shown him. He spent his final years under house arrest, but his work endured. His drawings, his words, his courage to believe what he saw. Picture him, old and nearly blind, still imagining the moons of Jupiter spinning silently, endlessly, beyond the reach of censure. Kepler. Harmony and ellipses. Johannes Kepler was a mystic and a mathematician. He believed in harmony, that the planets moved to music too faint to hear. Using the meticulous data collected by Tycho Brahe, Kepler discovered that planets move not in perfect circles, but ellipses. This shattered an ancient idea, but created something more beautiful, laws that could predict the sky's motion with stunning accuracy. Kepler's mind was full of music, math, and metaphysics. He worked through poverty, war, and loss. And yet he left behind equations that still guide spacecraft today. Imagine his cramped study in Prague. Candlelight casting shadows on geometric diagrams, his thoughts looping with orbits and harmonies. A sky made by many minds, these names. Aryabhata, Al-Biruni, Copernicus, Galileo, Kepler are only a handful. There were others, often unnamed. Translators who carried texts across languages. Teachers who explained the sky to children. Monks who copied diagrams in silence. Women whose work was erased or credited to others. Together, they form a quiet constellation, each one a point of light in the long story of how we came to know the stars. The sky above you tonight was shaped by all of them, and by those who remain unnamed. As we drift into the next segment, we turn to the cultural heavens, to myths, rituals, and the stories that shaped how people saw the sky long before equations were written. Before telescopes and charts, before observatories and satellites, the sky was sacred. Its mysteries were not measured but lived. Cycles shaped the rhythms of festivals, the timing of ceremonies, the meaning of life and death. In nearly every corner of the world, people looked upward and saw stories, omens, gods, and ancestors. The stars were not just distant fires, but symbols. The moon was not just a rock in orbit, but a timekeeper, a messenger, a guardian. In this segment, we leave behind the instruments and equations for a while and step into a world of sacred night, of chanting under starlight, of fires lit beneath constellations, of knowledge passed from elder to child by the flicker of flame. Constellations as storylines. For the ancient Greeks, the sky was a tapestry of myth. Orion the hunter, pursued by Scorpio. Cassiopeia, proud and punished. These figures still appear on modern star maps, their outlines traced in tiny points of light. But Greek constellations were only one system among many. In Australia, Aboriginal peoples saw dark constellations, not the stars themselves, but the dark spaces between them. One of the most famous is the emu in the sky, shape formed by the dust lanes of the Milky Way. When the emu's body rises in the right part of the sky, it signals the season to collect eggs. In Africa, the Dogon people of Mali described Sirius and its invisible companion star long before Western telescopes could verify its existence. Their sky lore was deep and precise, passed through generations in layered ritual and story. In the Andes, the Inca divided the sky into sacred regions. The Milky Way was a celestial river. Its position marked the agricultural calendar. Llamas, foxes, serpents, all were written across the night, their meanings encoded in festivals, plantings, and dreams. The stars were not silent. They spoke, but only to those who listened slowly. The zodiac and the celestial clock, the zodiac, now mostly known for daily horoscopes, had far older and broader roots. In ancient Babylon, the zodiac emerged as a system of celestial order. The 12 divisions of the sky allowed priests and scribes to track time, omens, and divine will. Later, Greek and Roman thinkers refined this system, associating each sign with elements, planets, and temperaments. The zodiac became a calendar of character as well as time. In medieval Islamic astronomy, the zodiac was studied both scientifically and symbolically. Astrological texts circulated alongside rigorous observational data, showing a world where spiritual significance and empirical knowledge were not necessarily in conflict. In India, the nakshatras, lunar mansions, formed an alternate system for understanding the moon cess passage and its influence. Marriages were timed to align with favorable celestial conditions. Festivals and rites followed the rhythms of these constellations. The zodiac wasn't just about fate, it was a mirror, one that reflected how people related to time, to the cosmos, and to themselves. Rituals under the stars across the world. Night was not just for sleep, it was for watching. In ancient Egypt, priests climbed to temple rooftops to track the rising of Sirius, whose heliacal rising foretold the coming of the Nile's flood. In Mesoamerica, Mayan astronomers built temples aligned to the movements of Venus and the Sun. Rituals of immense complexity unfolded in time with these celestial patterns. Battles, coronations, sacrifices. In Polynesia, navigators recited star chants to orient themselves across the ocean. These chants were long, rhythmic, and filled with imagery. They were sung, not written, remembered, not diagrammed. The stars were companions on voyages that stretched for thousands of miles. In Europe, midsummer and midwinter festivals tied to solstices gave shape to the seasons. Fires were lit at night, prayers spoke into the sky. The heavens were both a calendar and a cathedral. Even in quiet, humble villages, sky-watching rituals endured. A mother telling a child the story of the moon's phases, a shepherd noting the return of a bright star, a farmer waiting for the right constellation to begin sowing. The blending of science and spirit for many centuries, the distinction between astronomy and astrology was fluid. Kepler, whom we encountered earlier, cast horoscopes for patrons, even as he wrote laws of planetary motion. Galileo saw the sky's grandeur as proof of divine order. Newton, too, studied theology and alchemy alongside gravity and calculus. In cultures across Asia, Africa, and the Middle East, scholars studied the sky as both a scientific and spiritual pursuit. They mapped eclipses and predicted comets, but also read omens and searched for cosmic harmony. In today's scientific world, these practices are often labeled superstition, but to those who practiced them, they were deeply structured, meaningful systems, ways of aligning human life with a vast and mysterious cosmos. Sacred landscape, then and now, even now, in our electric age, remnants of sacred sky watching remain. Some traditions persist: stargazing festivals, equinox gatherings, the lighting of lanterns beneath full moons. Others have faded but still echo. Feeling of awe when you see the Milky Way far from city lights. A moment of quiet when a shooting star passes. A sense of something larger, older, watching back. To look at the sky is to feel both small and connected. It is a form of prayer without words, a question without an answer. In our next segment, we will return to earthbound tools, to the instruments that made the invisible visible. From bronze discs to brass astrolabes, to the great mechanical models of the cosmos. But for now, let the sacred sky remain. Let the myth swirl quietly with the stars, like smoke rising into the night. The 9th century in Baghdad. The Tigris River drifts slowly under moonlight. In the great city of learning, lanterns glow in courtyards where scholars gather beneath open skies. This is the era often referred to as the Islamic Golden Age, a time of flourishing science, mathematics, translation, and celestial study. It is here, in calm domed halls and rooftop platforms, that the sky was measured with new precision, not with superstition, but with tools. Not through conquest, but through collaboration. In this segment, we walk slowly through these ancient observatories. We linger among scrolls, among instruments of brass and ink, among scholars whose names may be unfamiliar, but whose calculations echo through modern science. The House of Wisdom in Baghdad. Founded in the early 9th century by Caliph al-Mun, the Beit al-Hikmah, the House of Wisdom, became one of the most important centers of learning in the medieval world. More than a library, it was a place of translation, debate, and innovation. Here, scholars translated works of Greek, Persian, and Indian astronomy into Arabic. They preserved the works of Ptolemy and expanded upon them. Al-Mun, fascinated by the stars, sponsored astronomical observations himself. He gathered astronomers to create new star charts, refine the length of the solar year, and even measure the circumference of the Earth. Using careful calculations, based on the angle of shadows cast at different locations, the scholars of Baghdad weren't merely copying knowledge. They were testing it, refining it, and integrating it into a new, coherent worldview. The air in the observatory was dry and still, the perfect companion to mathematical thought. Imagine the quiet scratch of a reed pen on parchment, the soft ticking of a water clock nearby, the muffled murmur of starlight being translated into numbers. Al-Khwarizmi and the foundations of celestial mathematics. Among the scholars working at the House of Wisdom was Muhammad ibn Musa al-Khwarizmi. Though he is better known today as the father of algebra, his contributions to astronomy were also profound. He wrote Zij al-Sindin, Hind, one of the earliest comprehensive astronomical tables in Arabic, adapting Indian methods to suit new mathematical frameworks. Al-Khwarizmi helped standardize timekeeping and calendar systems across the Islamic world. His work would become the foundation for later astronomical handbooks, many of which were used for centuries in Europe and Asia. He worked with an eye toward precision, yet always embedded within religious and practical needs. Prayer times, determining Qibla and the lunar calendar. His algorithms, a term derived from his name, would later guide the digital era, but they began with stars. Raga Observatory in Nasir el-Din, Al-Tusi, centuries later. We find ourselves in 13th century Persia, standing in the long corridors of the Moraga Observatory. Founded by the polymath Nasir al-Din al-Tusi, Moraga was more than a building. It was a project of intellectual resistance, constructed during the Mongol Ilkhanate and sponsored by Hulagu Khan. Al-Tusi designed it to study planetary motion, eclipses, and other celestial events. Using observational towers, libraries, and mechanical models, the scholars here revised Ptolemaic systems, paving the way for future astronomers like Copernicus. Tusi's tuple, a mathematical device for generating linear motion from circular motion, would later appear. Without credit in Renaissance Europe, but within these stone walls, the aim was never fame. It was accuracy, harmony, understanding. The observatory faced the sky with patient eyes. Samarkand and Ulugh Beg's grand project. Further east, in the 15th century, in the turquoise-tiled city of Samarkand, Ulugh Beg, a timid prince and passionate scholar, built one of the most advanced observatories of the pre-modern world. Ulugh Beg was a ruler, but preferred the night sky to politics. He taught mathematics and astronomy at his madrasa, and gathered experts to construct vast instruments, including a massive sextant aligned with the meridian carved into stone. With this, his team measured the length of the year with remarkable accuracy, off by less than a minute. Their star catalog listed over 1,000 stars, improving upon Ptolemy's work and preserving precision in a time when Europe was still emerging from medieval cosmologies. Ulugh Beg's fate was tragic. Assassinated by his own son, his observatory abandoned. Much of his work lay buried in the dust for centuries. But the stones still remember. The instruments still point to the heavens. A legacy carried forward, from Baghdad to Samarkand, from ink to stone, from parchment to starlight. The Islamic golden age of astronomy was not a footnote. It was a cornerstone. Many of the instruments used in Renaissance Europe were refined versions of Islamic designs. Many of the terms, azimuth, zenith, alidade, still echo their Arabic origins. But more than tools or tables, these observatories gave the world something subtler, a model of knowledge as a shared, cumulative endeavor. Science not as conquest, but as caretaking. Astronomy not as domination, but as devotion. The sky, after all, belongs to no one, and yet it invites everyone. Why? As we leave the observatories behind, we turn to a new kind of journey, the way humans began to navigate not just knowledge, but the world itself by the stars above. Now imagine yourself on the open sea. No land in sight, no map in hand. It's waves that breathe like lungs beneath the hull of your boat, and the sky stretched above, calm and eternal. In this darkness, a new kind of astronomy comes alive, practical, intimate, born not of observatories, but of experience. In this segment, we explore how the stars became waypoints, companions, quiet guides for sailors crossing vast oceans and endless deserts. To navigate is to know the sky, not through charts, but through memory. The Polynesian star pathfinders long before European explorers crossed the oceans. The Polynesians using nothing more than canoes, instinct, and the heavens, reached far-flung islands scattered across the Pacific. From Hawaii to New Zealand, from Tahiti to Easter Island, they traversed thousands of miles of open sea. How? Through a method known as wayfinding. Polynesian navigators used star lines, memorized sequences of stars rising and setting on the horizon. To steer their boats across the water, they studied the way the ocean swells curved, how seabirds flew at dawn, how clouds formed over distant land. At night, the stars provided orientation. Each rising star had a specific position, When that star reached its zenith, the navigator knew they were on course. No compass, no sextant, just memory, rhythm, and observation. Sky was not just a map, but a song. Star charts were chanted, passed down orally, layered with metaphor and history. A master navigator did not only watch the stars, he listened to them. Arab mariners in the celestial compass far to the west. Arab sailors plied the waters of the Indian Ocean and the Red Sea. From Oman to Zanzibar, from Aden to Calicut, their dhows carried spices, textiles, and stories. They too relied on the stars. Using the pole star as a northern anchor, Arab mariners developed precise systems of celestial navigation. The rising and setting positions of stars were recorded and passed along maritime routes. These observations became embedded in poetic verses, easier to remember during long voyages. Arab navigators also refined instruments like the kamal, a small wooden card with a knotted string, used to measure latitude based on the elevation of a star above the horizon. Simple, portable, and reliable. These tools, though humble, enabled long-distance trade and cultural exchange across regions. The star knowledge of these mariners blended astronomy, astrology, and geography. Their sky was practical, but also spiritual. The stars were signs, not just of position, but of timing, fate, and divine rhythm. Celestial navigation in medieval Europe. Navigation was less precise for much of the early period. Sailors often hugged coastlines, unsure of how to chart position across the open sea. That began to change in the 12th and 13th centuries, as translated Islamic texts and tools reached European ports. The astrolabe and mariner's quadrant became more common. Monasteries preserved star tables, and ports began producing simple almanacs. By the 15th century, with the age of exploration on the horizon, the stars became central to navigation. Portuguese sailors charted courses around Africa using stellar altitudes. Spanish explorers learned to read the Southern Cross in new hemispheres. The skies slowly became a global map, still incomplete but increasingly shared. Yet still the night sky was never only technical. For a sailor on a wooden ship thousands of miles from home, the stars were comfort, a steadying presence. The same constellations they had seen from the shore now watched over them at sea. Memory as a map. Unlike modern navigation, which relies on satellites and real-time tracking, ancient star navigation was stored in the mind, in chants, in whispered instructions passed from master to apprentice. To become a navigator was to become the map. You did not look at a chart. You became the chart. You embodied the ocean, the wind, the stars, and the silence between them. It was not only a science, but a trust. In the sky, in your own memory, and in the whispered wisdom of those who came before. There are still some today who practice these ancient methods. In the Polynesian tradition, navigators are still trained to sail without modern instruments. Reviving and preserving this quiet mastery of the stars. A night ocean that never ends. Even today, air and sea navigation still nods toward the stars. Satellites orbit where the stars once guided. GPS constellations named deliberately now serve the role that the night sky once played for all humanity. But beneath the surface, that older rhythm remains. To look up at the stars on a long journey is to feel anchored to something older than language. The same stars watched over our ancestors as they crossed deserts and oceans. They did not shine brighter then, but perhaps we noticed them more. As our journey continues, we will now explore how the stars shaped not only navigation and story, but also time itself, how they marked the seasons, divided the night, and kept pace with the lives of those on land. The sky is a clock that never stops ticking. Long before humans measured time in hours and minutes, they looked up to know when to plant, when to harvest, when to gather, and when to rest. In this segment, we slow down to explore how the rhythms of the heavens shape the rhythms of ordinary life. On farms, in temples, in village squares, and at the edge of forests. From ancient calendars to quiet rituals, the stars told stories that guided survival. We will move through the seasons, through fields and feast days, tracing how the movement of the sky was once woven into every gesture of daily life. The agricultural calendar, imagine a small village in ancient Mesopotamia. The soil is soft with early spring rain. Farmers look to the east in the early hours, watching for a particular star, Sirius. Its heliacal rising, when it first appears just before dawn, signals the coming of the flood. The Tigris and Euphrates swell. It is time to plant. In ancient Egypt, this same star marked the flooding of the Nile. The fields were prepared based on the heavens. Harvest came in accordance with the constellations. The sky did not just mark time, it became time. Across ancient China, farmers consulted detailed almanacs, many based on celestial observation. The lunisolar calendar divided the year into 24 solar terms, each one marking a shift in the natural world. Dew begins to fall, insects retreat underground, frost begins to appear. In medieval Europe, the phases of the moon and the position of the sun against the zodiac guided agricultural tasks. Even into the 19th century, farmers still looked to planting by the moon, timing crops according to waxing and waning lunar phases. Beneath every planting, a rhythm.
Oh!
Above every field, a watchful sky. Festivals and celestial markers where there is planting, there is also celebration. The same stars that told you when to dig also told you when to dance. Solstices and equinoxes, the turning points of the year, were marked with fires, songs, and sacred rites. In ancient Britain, structures like Stonehenge aligned with the solstices, turning the longest and shortest days into communal events. People gathered to mark the sun's pause and renewal. The winter solstice brought rituals of light in the darkest season. From Saturnalia in Rome to Yule in the north, communities celebrated the return of lengthening days. In South Asia, harvest festivals like Pangal and Makar Sankranti are aligned with the sun's entry into Capricorn. The sky signals that crops are gathered, debts repaid, and fires lit in thanks. In Japan, the Obon festival honors ancestral spirits and is timed around the midsummer alignment of lunar and solar cycles. Lanterns are released into rivers to guide the souls home, an echo of stars on water. These celebrations were not arbitrary. They were deeply embedded in the sky's rhythm, bringing meaning to the cycles of birth, work, death, and renewal. Timekeeping and the bell tower sky. As cities grew and mechanical clocks emerged, time was pulled downward from the stars and onto the street. But even in the medieval towns of Europe, time was still loosely synced to the sky. Bells rang at canonical hours based on solar time. Monks woke at matins, prayed at lauds, broke bread after prime, all coordinated with the slow movement of the sun and moon. In Islamic cities, the muezzin's call to prayer followed celestial calculations. Astrolabes helped determine the correct prayer times. The sky, even as the day became sliced into parts, remained the authority. Calendars, too, reflected this balance. Lunar months adjusted with solar years, giving rise to complex intercalation systems, like the Jewish lunisolar calendar and the Chinese calendar, all harmonizing with the cosmos. Timekeeping became more precise, but it never lost its origin. The clock tower may have replaced the sundial, but the stars still whispered their ancient cues. Folk beliefs and nighttime rituals. For many, the night sky was more than a schedule. It was a realm of signs and symbols. In rural Europe, a ring around the moon was said to predict rain. A shooting star could signal a soul passing or a wish granted. Certain stars rising at dusk marked danger or fertility or war. Shepherds learned to tell the time by the stars. Hunters knew the best hours from lunar light. Mothers taught children lullabies based on constellations. In Andean villages, the Pleiades cluster was watched closely. A dim appearance warned of drought. A bright one foretold a good harvest. The stars were a language of caution and comfort. Even in early modern towns, people marked major life events, births, marriages, deaths, with horoscopes. The alignment of celestial bodies shaped perception, decision, and direction. This wasn't science as we know it today, but it was a kind of knowledge rooted in generations of observation. It connected sky to soil, stars to sleep, night to the human heart. The stars above the hearth. As the segment draws to a close, return again to a quiet night. The hearth is warm. The fields are asleep. Outside, the stars continue their ancient circuit across the dark sky. For the people who lived before electric lights, before digital calendars and atomic clocks, the stars were always there. Not distant or abstract, but close and personal. They rose and set with gentle reliability, whispering not in words but in rhythm. A reminder that time moves not in straight lines but in circles. And that long before we look to the stars for science, we look to them simply to live. From the rhythm of seasons, we now move toward a different rhythm, the one that led to the discovery of other worlds. A rhythm of telescopes, of expansion, of a shift from Earth to space. We now enter a period when the sky began to be measured with greater precision, observed with instruments rather than only eyes, and interpreted through the lens of mathematics rather than metaphor. But the rhythm remains slow. The turning of the heavens continues quietly overhead, even as the ways we observe it become more elaborate. This segment explores how astronomy entered a new era, not only through the invention of tools like the telescope, but also through the emergence of institutions, universities, and observatories that formalized the study of space. Here, we gently transition from the personal to the professional, from the village field to the academic dome. A lens to the sky. It begins in the early 17th century with a modest tool, the telescope. In the Netherlands, spectacle makers had begun experimenting with lenses. These instruments were originally built to observe things on Earth, but soon their potential was turned upward. Galileo Galilei in 1609 crafted a telescope strong enough to reveal the moon's craters. He observed the moons of Jupiter and the phases of Venus, each one a quiet revolution against the old understanding of the universe. Before the telescope, the sky was a flat canvas. After it became a deep well of detail. The stars were no longer only points of light. They had structure, motion, and companions. With every new lens, the heavens became less symbolic and more complex. No less beautiful, but far more intricate. The observatory era, as the telescope evolved, so too did the spaces in which it was housed. Across Europe, dedicated observatories began to appear, often connected to universities or royal courts. In England, the Royal Greenwich Observatory was founded in 1675. Its role was not only scientific, but practical to improve navigation at sea, calculate the longitude, and anchor the empire to a stable measure of time. In France, the Paris Observatory gathered astronomers under a single roof, fostering collaboration and consistency in celestial measurement. Germany, Italy, Denmark, and Russia followed, and by the 18th century, observatories dotted the map, each contributing slow but steady knowledge to humanity's understanding of the cosmos. These buildings were not yet the massive domes we know today. They were often small towers or garden structures, housing delicate instruments and meticulous scribes. But their gaze was constant, methodical, and deeply rooted in tradition. celestial mechanics and the clockwork universe with observations came theories. Newton's laws of motion and gravity, published in the late 1600s, offered a framework for understanding the movement of the planets. The heavens, once believed to be unpredictable or divine, now appeared to follow patterns. Like a clock, elegant and precise. The planets, comets, and moons became predictable. Their orbits could be calculated, their positions forecast years into the future. The idea of a mechanistic universe took hold, not devoid of wonder, but governed by knowable laws. This marked a quiet shift. Stars remained distant, but no longer mysterious. For some, this predictability was comforting. For others, it removed the mystical veil. But in either case, the study of the sky became a matter of numbers, diagrams, and observations noted carefully in ledgers. Women in the dome, even as institutions grew, many of the most patient observers of the sky remained in the background. Women, often excluded from universities, found roles as assistants, computers, and quiet observers. In England, Caroline Herschel, working alongside her brother William, discovered comets and cataloged the sky in great detail. In America, at the Harvard Observatory, women known as computers, including Annie Jump Cannon and Henrietta Leavitt, classified stars and discovered relationships that would later help measure galactic distances. Their work, often done in silence and shadow, was foundational. Their eyes caught what others missed. Their calculations refined the data. Their legacy, though often unrecognized at the time, remains written in the sky's recorded history. The world begins to watch together. By the 19th century, astronomy became more global. Telescopes were built in the southern hemisphere, revealing stars unseen from the north. International efforts began to share observations. Star charts were standardized. The concept of universal time became essential. And yet, even as precision improved, the feeling of watching the stars remained deeply human. Astronomers still spent long nights at eyepieces, sketching what they saw by hand. Observations were made in silence, punctuated only by the turning of gears and the scratching of pencils on paper. It was still a quiet science, still ruled by patience, still steeped in solitude. An expanding horizon. This segment marks a threshold. No longer are the stars simply companions of farmers or sailors. Now they are subjects of study, of catalog, of prediction. The sky becomes a data set. But in doing so, it also becomes a universe. Vast, structured, and slowly expanding in the mind. As we move forward, we will begin to leave Earth behind. The stars we have gazed upon for millennia now invite us to listen more deeply, to capture their invisible signals, to search for messages that might not be meant for us and yet arrive all the same. Go from the optical to the radio, from what we can see to what we can only hear. We continue next with a new kind of listening. The eyes of astronomy were once bound to the visible. Human sight, through glass and lenses, defined what we knew of the stars. But as technology advanced, so too did the senses we use to understand the universe. In the 20th century, we began to listen. Not with ears, but with vast, quiet dishes spread across fields and mountaintops. These were the ears of modern astronomy, and they opened up a new sky, a radio sky. This segment explores the emergence of radio astronomy. It's a dream of communication with other intelligences and the patient, quiet work of listening to the cosmos. A story not of signals received, but of enduring curiosity and the beauty of unanswered questions. A new kind of telescope. The story of radio astronomy begins with a hiss. In 1931, Carl Jansky, an engineer with Bell Telephone Laboratories, was investigating sources of static that disrupted radio transmissions. He built a rotating antenna, a strange spider-like structure, and discovered something curious. There was a steady, faint signal coming from the center of the Milky Way. It was the first whisper of the universe beyond the visible. A low, invisible hum that no one had heard before. Soon after, other engineers and scientists began to build radio telescopes. Large, parabolic dishes designed to detect radio waves emitted by stars, galaxies, and celestial phenomena. Unlike traditional telescopes, these instruments worked day or night. They did not need clear skies, and they revealed things the eye never could. Remnants of ancient supernova, distant quasars, and the cosmic background of the early universe. The sky, once a map of dots, was now a sea of invisible sound. The silent search for intelligence with the ability to listen came a new idea. What if someone, or something, out there was sending messages? In 1960, astronomer Frank Drake conducted Project Ozma, the first scientific attempt to detect signals from intelligent extraterrestrial life. He pointed a radio telescope at nearby stars, scanning for patterns, something more structured than the randomness of nature. There was no reply, but the effort sparked a movement. The search for extraterrestrial intelligence, or CTI, became a scientific field of its own. Arrays of radio telescopes listened to the cosmos, scanning for narrow bandwidth radio signals not produced by nature. The famous Arecibo Observatory in Puerto Rico, for decades the world's largest radio dish, became a symbol of this quiet vigil. No confirmed signals have ever been found. But the silence is not meaningless. It tells us something too. About distance, about time, about our own longing. The universe as we understand it is vast beyond measure, and listening to it patiently, gently, has become one of the most enduring acts of science. Messages we sent, we did not only listen, we also sent greetings. In 1974, the Arecibo Observatory broadcast a message toward a distant star cluster, the Arecibo message. Encoded in binary, it contains simple data, numbers, chemical elements, a depiction of DNA, a sketch of the human form. Voyager 1 and 2, launched in 1977, carried golden records, phonograph discs engraved with the sounds and images of Earth, music, greetings in dozens of languages, whale songs, and laughter. These spacecraft drift silently beyond the solar system. Their golden records now cruise through interstellar space, unread and unknown. Tiny echoes of us in the cosmic dark. We do not know if they will ever be found. But sending them was a statement, not of certainty, but of wonder. The art of listening. Radio astronomy is by its nature a patient science. Single burst might take years to confirm. Repeating pattern might be natural or instrumental or something stranger. There is more noise than signal. But within that noise are stories of galaxies forming, of stars dying, of the background hum left from the Big Bang. Some signals are regular and strong, like pulsars, neutron stars spinning and emitting steady beacons. Others are fleeting and rare, like fast radio bursts, brief, intense emissions of energy whose origins we are still trying to understand. Astronomers must listen carefully. They must distinguish between interference from Earth and true cosmic messages. They must wait. The act itself becomes a kind of meditation. To listen with no guarantee of answer. To wait without impatience. To sit in the quiet presence of the universe. Cosmic loneliness, cosmic company, the radio sky reminds us that we are small, but not isolated. Every wave we detect, every echo we chase is a connection to something far beyond us, a star thousands of light years away, a galaxy in the earliest years of the cosmos, a signal that has traveled longer than human history itself. We listen not only to discover others, but to better understand ourselves. In the static, there is structure. In the silence, there is music. In the waiting, there is meaning. And so we continue to build arrays and dishes from the plains of South Africa to the deserts of Australia. We link them together into networks, stretching across continents. We listen with more sensitivity than ever before. Still, the stars remain quiet, but not indifferent. They burn, they emit, they sing, whether or not anyone listens. In the next segment, we'll return to the most ancient signal of all, not from a star or a planet, but from the very beginning of time, a faint glow still echoing through space, left behind from when the universe was very young. We have watched with our eyes, listened with our antennas, and mapped the stars with instruments ancient and modern. Yet even beyond the stars themselves, there is more, a whisper fainter than all others, filling every corner of the sky. This is the story of the light between stars, a light so old it predates stars altogether. A remnant not of suns or galaxies, but of the beginning itself. This final segment explores how we came to know about the universe's origin, how that faint background glow carries echoes of the birth of everything, and how in studying it, we find ourselves once again standing quietly under the sky in awe. The gentle glow from the beginning. In the 1960s, two engineers at Bell Labs, Arno Penzias and Robert Wilson, were trying to eliminate noise from a radio antenna. They had built a horn-shaped receiver, sensitive to microwave frequencies, and they found that no matter what direction they pointed it, there was always a faint hiss. At first, they assumed it was a fault, a technical issue. Even pigeon droppings were cleared from the instrument in an attempt to quiet the noise, but the sound remained. What they were hearing was not from Earth, nor from any nearby star or galaxy. It was the cosmic microwave background radiation, the cooled echo of the Big Bang. This radiation fills all of space, equally like a gentle fog. It is the afterglow of a fire that burned nearly 14 billion years ago. Not hot anymore, but still glowing softly. The discovery earned them a Nobel Prize, but more than that, it offered evidence that the universe had a beginning, a moment of incredible density and heat that expanded rapidly and has been expanding ever since. Time as a landscape, as astronomers refined their measurements of this background radiation, they began to see something else. The universe had structure, even then. There were tiny fluctuations, gentle ripples in the uniform glow, which would later become galaxies, stars, and planets. The early universe was not entirely smooth. Those small imperfections, those minuscule differences in temperature, were essential. They were seeds. From them, all structure would grow. Like patterns in sand shaped by wind, the early universe held the promise of everything that would come, from galaxies to single-celled organisms. From moons to human minds, the light between stars became a kind of time machine. Looking at it, we were no longer observing just distant places. We were seeing distant moments. The farther we looked, the older the light became, and the more ancient the universe appeared. Telescopes, like the Hubble and later the James Webb Space Telescope, were built not just to peer farther, but to look deeper into time itself. And what they revealed was not chaos, but elegance, a gradual unfolding, a soft swirling choreography of matter and energy, slowly cooling, slowly coalescing, slowly becoming everything we know. From silence, a symphony. The sky above us is not silent. It hums with radiation. It whispers in particles. It sings in wavelengths too low for ears, too high for eyes. Every point of light, every patch of darkness, holds a story. And perhaps the most calming truth of all is this: the universe does not hurry. Stars take billions of years to form, live, and fade. Galaxies rotate slowly. Clouds of gas drift for millennia before collapsing into suns. There is no rush, only time. From the first moments after the Big Bang to the formation of our solar system, from ancient Babylonian star maps to golden records launched into deep space. The journey has been long and wandering, like a quiet walk under stars that always move, but never seem to leave. Looking back, drifting forward, and now, here we are. Listeners, observers, dreamers. In a time of satellites and simulations, the sky still holds the same quiet power. Even with all we've learned, it remains an invitation. To wonder, to reflect, to sleep beneath its watchful glow. You might think now of how many eyes have looked up, how many questions were asked in silence, how many thoughts were stirred by a single star on a cold night. The sky has watched over every age, from the Ice Age to the Information Age, and even as our tools change, the wonder remains. In all the vastness, we still find comfort. Closing. A quiet night beneath the cosmos. As we come to the end of this long, gentle journey, let the night settle around you. Let your thoughts drift like constellations, slow and meandering. The stars are still out there, turning slowly above us, just as they did for the monks of Ireland, the poets of Persia, the Skywatchers of the Maya, and the scientists of modern time. They do not rush, and neither must you. Close your eyes if they are not closed already. Let the stories fall away. Let the silence expand. There's no need to reach for meaning now. The sky has always been more than we could hold, more than we could name. And yet we have named it anyway, again and again across centuries and continents. Tonight, it holds you too. Good night, traveler of time and stars. Sleep well beneath the ancient, endless sky.